Amino acids. Amino acids. So amino acids make up proteins. Proteins are made from amino acids. The general formula of an amino acid, general formula, is RCH NH2 COOH. Okay, so if you were to draw that out, we've got the center carbon and a H and an R group. Remember, R can be alkyl, methyl, ethyl, but it doesn't have to be an alkyl, it can be various other things as well. Carboxylic acid and an amine. So it's a special type of molecule because it's got a carboxylic acid and an amine. A lot of amino acids have optical isomers because you've got a chiral carbon atom, a chiral center, a carbon atom with 4 different groups, and so you'll get 2 optical isomers. Now this is called an alpha. The one I've drawn here is called an alpha amino acid. And it's called an alpha amino acid because the carboxylic acid and the amine are joined to the same carbon. If you have a beta amino acid, for example, we take the center carbon, is when there is one carbon separating the amine and the amino group and the carboxylic acid. So that would be an example of a beta amino acid. Now the 2 amino acids you need to know are glycine. Glycine has the formula, it's the simplest amino acid. It's when the R group is a H, and it's the simplest amino acid. There is no chiral carbon atom, so there are no optical isomers. The next simplest one is alanine, and alanine is when the R group is a CH3, the second simplest amino acid. Okay, and this does have optical isomers because you've got a chiral carbon atom. So remember, when you're drawing your optical isomers, the first thing you do is you draw your 3D shape, the tetrahedral shape. You draw the mirror image, the non-superimposable mirror image. Okay, so I'm going to fill in COOH, COOH, NH2, NH2, doesn't matter where you fill it in, H, CH3, CH3. What is important is connectivity. The C is bonded to the C, the C is bonded to the C, C to the N, C to the M. And this is non-superimposable mirror images. Non-superimposable mirror images. Optical isomers. Okay, right. If we take, let's take alanine again. Okay, what's the systematic name? That's the common name, is alanine. But what's its chemical name? So its chemical name is so it's if you ignore that, it is propanoic acid. Okay, propanoic acid is its chemical name. Propanoic acid, and then you bring this in, and this is on carbon 1, 2, so it's 2-amino propanoic acid is the chemical name for alanine. Right? So what else do we need to know? So it's quite special because it's got 2 functional groups in one molecule. It's quite special. So if we take alanine again, alanine, right, is you've got an acidic proton, and you've got a base, an acid and a base, all within one molecule. Okay, so that's acidic end, and you've got a basic end. And so it is an internal salt. An internal salt. The H plus here, the H plus can be donated and then accepted over here. So you get, when it's accepted, you get H3N plus, C, CH3, H, C, O minus, like that. Okay, so the H plus has been donated, it's an acid, it's been accepted by the the base, and this happens within the molecule. It's called internal salt, and the name we use for it is a Zwitter ion. Be careful with your spelling. A Zwitter ion is a German word, German origin, a Zwitter ion. And this is when this internal salt has happened and there is no overall charge. No overall charge. Now there's something called an isoelectric point. So if the question says what is the isoelectric point of an amino acid? What is the isoelectric point of an amino acid? Then the isoelectric point, this is definition, the isoelectric point of an amino acid is the pH value at which the amino acid exists. At which the amino acid exists as a Zwitter ion. Okay, so the isoelectric point is the pH at which the amino acid exists as a Zwitter ion. Right, so say every amino acid has its own pH value. Okay, so in water, this is what will happen in water. And if we take alanine in water, the pH of the water will have a value, and it's approximately 6. Okay, so just draw this out, an amine. Okay, oh sorry, no, so that in the Zwitter ion of alanine has an isoelectric point of pH 6, and that's when the pH at which the Zwitter ion exists, and that's in water. Okay, so if you have your amino acid in water, it'll be pH 6. I think it's actually 6.01, okay, to be super accurate. Okay, so if you then add acid, if you put your amino acid into acid, okay, and you surround the whole of the Zwitter ion with acid, then what you end up with is this stays as a plus, but then this bit here becomes a carboxylic acid. So in acidic solution, say if it's like pH 1, we put the amino acid into some acid solution. That's the form of the amino acid. If we put this amino acid into an alkaline solution, I don't know, like pH 11 for example, then the alkali will suck out all the H pluses. So the form of this amino acid in alkali, it'll take off all the H pluses to form water. So that will lose its H plus. There will be no H pluses. So alanine, that's the form in water. That's the pH of it in water. You don't have to remember that. They always give you that. Then in acid, you put H plus wherever you can. In alkali, you put you remove the H plus. Okay, so let's have a go. Let's put one more thing as well, actually, before we move on. One more thing. The fact that it can act, amino acids can act like an acid, or a base. The word for that is amphoteric. That can act like an acid or a base is amphoteric. Okay, let's have a quick go of a couple of examples and then we're finished. Right, so let's give you a couple of questions. First question. So you've got to write the formula. So write the formula of a salt that is formed when well, let's start this one first. This is not an amino acid, this is an amine. When ethylamine reacts with sulfuric acid. Okay, so this is not a amino acid question, I'm sorry, but let's just do it anyway because it's quite interesting. Right, the formula of a salt that's formed when ethylamine reacts with sulfuric acid. So you have ethylamine, which is an amine, and sulfuric acid. Okay, remember that amine has a lone pair of electrons, accepts the H+. There are 2 H+, so we're going to need 2 ethylamines. Okay, when it accepts a H+, it becomes NH3+, and there's 2 of them, and then you're left with SO42-. Okay, so that's the salt that's formed when ethylamine reacts with sulfuric acid. Okay, I wanted to give an actual amino acid question, so let's come up with an amino acid question. So how about this one here? So if we take this amino acid, okay, I'm just going to take me a second to draw it out, C, and then it is H, and then it is CH2, CH2, C carboxylic acid, okay, and C carboxylic acid, and NH2. Okay, so that's the R group. And this amino acid has an isoelectric point, of 3.22. That's a pH. So in water, when that is in water, the H+ here comes over here and forms the Svita ion. Okay, so at pH 3.22, the Svita ion will exist. The Svita ion. Okay. Now, why does it have such a low pH? It has a low pH because in the R group has a carboxylic acid, and that's why it has a low pH. If the R group had an amine, it would have a higher pH. Okay, so that's it in water, but what if we put it into acid? Well, if we put it acid, we empty it into acid. If we empty it into acid, wherever possible, you put a H+. So we're going to put a H+ back in there. So that's the form when it's in acid. If we put it into alkali, an alkali will remove all the H+. Remove H+, COO-, remove H+, COO-, remove H+, NH2. So that is what will happen if you put it into alkali.